Welcome to this GCSE Maths lesson on enlargement using a negative scale factor. Today, we'll explore what enlargement is, how it works, and the difference between positive and negative scale factors. Let's get started. Enlargement is a transformation where we change the size of a shape but keep its proportions. Think of it like zooming in or out on a smartphone. The shape grows bigger or smaller, yet its overall form doesn't get stretched or squished. When the scale factor is greater than 1, the shape gets bigger. For example, if a right triangle has a base of 3 centimeters and a height of 4 centimeters, and the scale factor is 2, all dimensions are doubled. So, the new triangle's base becomes 6 centimeters, and its height becomes 8 centimeters. When the scale factor is between 0 and 1, the shape gets smaller. Taking the same triangle, if the scale factor is 1/2 or 0.5, the dimensions are halved. So the base is now 1.5 centimeters and the height is 2 centimeters. Now, when we discuss about enlargements, there is one term that we always need to remember, that is center of enlargement. The center of enlargement is a fixed point from which all measurements are taken and scaled. This point plays a crucial role in determining how the shape is transformed. Throughout this lesson, we'll use the center of enlargement to guide our calculations and constructions. So what happens if the scale factor is negative? A negative scale factor places the enlarged shape on the opposite side of the center of enlargement and flips it upside down, almost like a mirror reflection through that center point. So, the shape moves to the opposite side of the center. It's flipped like a mirror image, and its size is determined by the absolute value of the negative scale factor. So if the scale factor is something like -4, the flipped image is 4 times bigger. Or if the scale factor is -1/4, the flipped image is 4 times smaller. Now, to better understand all this, let's do an example. For the figure given below, find the enlargement of the object with a scale factor of -2 about the center of enlargement at the origin. In order to solve this question, we will follow the following steps. Step number 1 is to mark the center of enlargement. In this case, it's the origin, 0, 0. For step number 2, take a ruler and measure the distance from the center of enlargement to one vertex of the shape. Let's call this vertex A. Suppose the distance from the origin to A is 5 centimeters. For step number 3, multiply the distance by the scale factor, ignoring the negative sign for now. 5 centimeters times 2 equals 10 centimeters. For step number 4, extend the line through A to the opposite side of the origin. Since the scale factor is negative, place the new point of prime 10 centimeters on the opposite side of the origin. For step number 5, repeat this process for all other vertices. Label the new points as B', C', and so on. Finally, for step number 6, join the points to form the enlarged, flipped shape. This final figure is the answer to our question. Now, let's try another question. This time the scale factor is negative, but in a fraction. For the figure given below, find the enlargement of the object with a scale factor of -1/3 about the center of enlargement at the point 1, 1. For this question, we will again follow the same steps. For step number 1, mark the center of enlargement at 1, 1. Let's label this point as C this time. For step number 2, take a ruler and measure the distance from the center of enlargement to one vertex of the shape. Let's call this vertex A. Suppose the distance from C to A is 3 centimeters. Now, for step number 3, multiply the distance by the scale factor, ignoring the negative sign. 3 centimeters times 1/3 equals 1 centimeter. For step number 4, extend the line through A to the opposite side of C. Since the scale factor is negative, place the new point a prime 1 centimetre on the opposite side. For step number 5, repeat for all vertices to get B prime, E prime, etc. Finally, for step number 6, join the points to form the enlarged, flipped shape. This example demonstrates how fractional negative scale factors flip the shape and make it smaller. Here's a quick comparison. If we have a positive scale factor, the enlarged shape stays on the same side of the centre of enlargement and does not flip. And if we have a negative scale factor, the enlarged shape flips and moves to the opposite side of the centre of enlargement. And there you have it. That's how enlargement using a negative scale factor works. If you enjoyed this video, be sure to leave a like and subscribe our channel Top Grade Tutor for more exams-related tutorials. Thanks for watching and see you next time.